Hello, my name is Rebecca Weaver. I'm going to be giving you an introduction on whole numbers today. So let's get started. First up, multiples and divisibility. We want to know if numbers are divisible by other numbers. First one we're going to look at is the number 2. We're going to see if different numbers are divisible by 2. A cool trick to use is that if you look in the ones place, the digit that's in the ones place, if it's a 0, 2, 4, 6, or an 8, then you know it is divisible by 2. So moving forward on this, if I look at 16 divided by 2 and I do that division, I find that that's 8 with no remainder. That means that 16 is divisible by 2. The number 15 has a remainder of 1 because 15 divided by 2 is 7 with a remainder of 1. 15 is not divisible by 2. 224 divided by 2 is 112 with no remainder. That means that 224 is divisible by 2. I could have just looked in the ones digit right here and noted that we had a number that was divisible. It was 4, so it was divisible by 2. Looking further, we're looking at a number which 3 goes into, or 3 divides into. Cool trick for this is just to look at the sum of the digits. And if the sum of the digits is divisible by 3, such as, oh, nope, let's look, 1 plus 6 is 7. 7 is not divisible by 3. Therefore, 16 is not divisible by 3. What about 15? I know 15 is divisible by 3. And 1 plus 5 is 6. And since 6 is divisible by 3, I could go ahead and do that division if I wanted to, but I don't have to because I know it's divisible by 3. Looking at the number 225, I don't want to do that division. So let's just add the digits. 2 plus 2 plus 5 is 9. 9 is divisible by 3. Therefore, 225 is divisible by 3. Cool. A number which 5 divides into. Okay, so we have a cool trick. If we look in the ones place, if it's a 0 or a 5, I know it's divisible by 5. The last digit is a 0 for 110. Therefore, 110 is divisible by 5. The last digit is a 5 for the number 65. Therefore, 65 is divisible by 5. Then the number 224, the last digit is a 4. 224 is not divisible by 5. That one's pretty fun. 6. Cool trick for 6. You can just go ahead and do the division if you want to, or you can remember this cool trick. If the number is divisible by both 2 and 3, and I have cool tricks for 2 and 3, so if the number is divisible by 2 and 3, it's divisible by 6. 82. Let's see. 82 ends in a 2. Therefore, 82 is divisible by 2. However, 8 plus 2 is 10, and 10 isn't divisible by 3. So 82 is not divisible by 6. Because if one of them fails, it's not divisible by 6. It has to be both because of that and. 228 ends in an 8. So 228 is divisible by 2. Adding those digits, 2 plus 2 plus 8 is 12. Therefore, 12, since 12 is divisible by 3, 228 is divisible by 6. And my favorite trick of all is tens. Just look at the ones place. If the digit in the ones place is a 0, it's divisible by 10. 55 ends in a 5. 55 is not divisible by 10. 25,340 ends in a 0. 25,340 is divisible by 10. Factors and prime factorization. So we need to know what each of these things means in order to be able to work these problems. If A times B equals M, then A and B are factors of M. What does that mean? Well, 4 times 3 is 12. So 3 and 4 are factors of 12. Now, if I wanted to do the prime factorization of that, 4 times 3 is not the prime factorization. To do prime factorization, I need the product of prime numbers that equals the number. So I would have to break that 4 down so that it was in terms of prime numbers. So it's 2 times 2 times 3. That's the prime factorization of 12. Another number, 5 times 12 is 60. I can say that 5 and 12 are factors of 60. But that's not the prime factorization because 12 breaks down quite a bit. 12 could be broken down into 2 times 2 times 3. That's his prime factorization. Then times 5 would be my 60. There's your total prime factorization. Least common multiple and greatest common factor. The least common multiple of two numbers is the smallest number that's a multiple of both numbers. Now, to find the least common multiple, just list out several multiples of each number and just select the smallest number that occurs for both. I've done that here. So I took the numbers 15 and 20. Listed out some multiples. I could have gone further. However, I saw that once I got to, once I got to it, let me get my ink here. Once I got to right here, notice how that 60 occurs in both. So we know that 60 is the smallest common number, so I'll call him the least common multiple. For greatest common factor, now the greatest common factor of two numbers is the greatest factor that is common to both. Now, to find the greatest common factor, what you need to do is list out all the factors of both numbers and select the greatest factor that's common to both. So if I look at 15 and 20, I list out those factors. I will get, 5. Looks like to me it's 5 for each of those. Notice how 5 is in both, and that's the greatest common factor to each. All right, that concludes our lecture on an introduction to whole numbers. If you have any questions, please email me, rweaver10@alaska.edu. Thank you and have a nice day.